Hello, I'm Channa Bankapur from Master Technologies. I'm going to discuss my solution to today's problem in October LeetCoding challenge. The problem is serialize and deserialize BST. So any data structure can be serialized into some kind of form which can be stored in secondary devices, secondary storage devices, and also useful for transmitting across the network. So there are more general standards like JSON and all. They can actually do the job pretty well. But this is a BST, right? So can we do it better here? So that's what the idea is. So that's why they have given this recommendation. The encoded string should be as compact as possible. So we should not be using a more generic, standards like JSON. So this is how it looks like. We have two methods to implement. One is given a tree, which is a BST. We should be able to serialize into a string, and given similar string, we should be able to deserialize into the same original BST. So how do we do this one? If it is a general binary tree, we have even more generic methods like using some kind of hierarchical way of representing the data using parentheses and all. But this is a BST, right? So even for a binary tree, if we store pre-order traversal and in-order traversal, we can always construct it back, right? I'm going to go with that idea. But here this is a BST, so we don't need even in-order traversal to be stored, because if I just know what is the pre-order traversal, a sorted version of that is going to be in-order traversal, right? So I'll use that idea. By the way, there is another problem in LeetCode, which is constructing BST from pre-order traversal. So what I have done here is pre-order traversal is given to us. I made a copy of that and then sorted it, right? So that is going to be my in-order traversal. So I used both pre-order traversal and in-order traversal to construct the tree back, right? So I'm going to use the same method so that we can just store the tree in the pre-order traversal of the tree in the form of string, and the string data what we get is going to be the pre-order traversal, and we can use the same method. Let me show my code. Serializing method is very simple. So we just need to get the pre-order traversal. So that's what I have done here. But yeah, between the elements, I'm going to just have one space. So that's why first I include the root value, and after that I'm calling. I just need the similar serializing method, but I need a space in between every value where we print into the string. So that's why I have a helper function. The only difference in the helper function is I have an extra space here before any new value being printed. All right. So with that, that this is going to serialize. So serialization method is very simple. And now how does deserialization work? So I get the data in string form. So the base case I handle here, and then I convert that data into a vector, which is the pre-order traversal. So this string to vector is the method I have implemented here. So here I'm just using some string stream to generate the whole, get each number in that stream, and then pushing it into the vector, right? So after that, I have pre-order traversal of vector, and then the following method is very similar to the other problem. I'm gonna have a copy for in-order traversal and sort it so that I have in-order traversal, and then I'm gonna use the same old method of BST from pre-order, which is gonna do the job. I haven't done any changes from the previous method, right? So this is gonna work. Let me submit and make sure. Yeah, it works, and it works pretty fast, right? So this is the method I have. Let me know if you know any other method which is going to be a little more compact form than this, and also works almost as fast as possible. All right. Thank you for watching. Please like the video and subscribe to the channel.